In our next two applied examples, we want to look at how we can find intercepts and interpret end behavior for a given function and apply that to some practical results. In example 14, the number of women aged 16 years and older in a certain country's civilian labor force can be modeled by the function below, where W represents the total number of women in the civilian workforce in millions, X years after 1900. We want to use Wolfram alpha to find the x-intercept for this function and then interpret that result. To do that, we'll ask Wolfram alpha to find intercepts for this given function. Should be to the third power. We get both an x-intercept and a y-intercept, but we're only interested in the x-intercept of 26.939, meaning we have an x-intercept at the point 26.939, comma 0. Then in part B, we want to interpret this information. This means that in the year 1927, we get that from approximating our x-coordinate to be about 27. X represents years after 1900, so 1900 plus 27 puts us in the year 1927. There were 0 women in the country's civilian workforce. We get that from our y-coordinate, which in this case is W equals 0. So our x-coordinate occurs whenever our y value is 0. So what we're finding is the last year that there were 0 women in the civilian workforce in this particular country. As time goes on, the number of women in the civilian workforce in this country will either be increasing, decreasing, remaining constant. We can look at the function that we're given to determine this information. But we need to do a little bit of work to our function first, because the way that it's not written in standard polynomial form. So we don't need to multiply all of this out, but we need to get a feel for what the beginning of this would look like if we were to expand it. So this would become 0.0007, and then if we were to multiply all of this out, we would eventually get x cubed, and then plus some other terms. We don't care about those other terms because we just care about the term with the highest power, which would be x cubed. And then when we distributed through, we get 0.0007 x cubed plus, again, some other terms. So we want to look at just this leading term and interpret that information. We know that it's an odd degree, so our curve is going to look like this. And our value for a is greater than 0. So that means that based off this function, the number of women in the workforce will continue growing because this is a third degree polynomial with a leading coefficient that is positive. So what we're really saying there is as x approaches positive infinity, our function w of x will also be approaching positive infinity. In example 15, we're told that since 2000, voter registration in a particular country has been decreasing according to the function below. We want to use Wolfram alpha to find all x and y intercepts. So we'll again ask for intercepts 4, but update to this new function. Just 2 zeros there, 0.003 times x minus 44.742 cubed. And we get 1 x-intercept, 1 y-intercept. So our x-intercept occurs at 44.7420, comma 0, and 0, comma 268.7. Then we want to interpret this information. The first one is asking us something about what's happening in the year 2000. The year 2000 is our year t equals 0, since x is years after 2000. So this is telling us that there were t equals 0, 268.7, where registered voters is in millions. So we need to take our y coordinate times 1 million to get 268,700,000 registered voters in this country when t equals 0, or in the year 2000. That's the interpretation of our y-intercept. To interpret our x-intercept, we're told that by the year, in this case, 44.472, which is approximately 45 years after the year 2000 would be 2045. So in that year, there will be 0 voters, registered voters in this country, since v equals 0 is our y coordinate for this point. Then we want to use Wolfram alpha to find v of 32, meaning we want to evaluate this function at x equals 32. So I'm just going to update what I already had there, replace the x with 32, and I get a value of 6.206, and so on. Again, to interpret this, we need to take that function value times 1 million, which is telling us that there will be 6,206,318 registered voters in this country in the year t equals 32, so 2032, 32 years after the year 2000.